Welcome to the Deep Dive. This is where we really try to get past the surface level and, give you the core insights on complex tech topics.
Yeah, cutting through the noise.
Exactly.
Mhm.
So today we are doing a pretty critical analysis, I think, of what's next for managing infrastructure. We're talking AI-driven networking.
Great topic.
Huge. And specifically, we're zooming in on Juniper's Mist AI platform. We want to kind of dissect the architecture, the features, basically what makes it tick and why it could, really change things for enterprise networks.
Sounds good.
Our source material today, it's pretty solid. It comes from practice analysis tied to the JN0-750 JNCIP-Mist AI curriculum. So our mission isn't just listing features.
Right.
It's about pulling out the strategic stuff. Like, how does Mist AI actually change the way people work, the way users experience the network?
That's the key, isn't it? We're looking beyond just the specs and really focusing on the disruption. I mean, if you're listening to this, you probably know this isn't just another update. It's a fundamental shift philosophically in networking. So maybe let's start right at the core purpose. Why bring AI into networking? What's the main job Mist AI is supposed to do?
Okay, yeah, let's unpack that because it sounds like the main idea isn't just, configuring boxes and checking for green lights anymore.
Precisely. That's the old way. The main purpose, the big idea behind Mist AI, is to deliver these comprehensive, AI-driven insights and automation.
Right.
And that's for the whole network, wired and wireless.
Right.
Historically, networking was, let's face it, reactive.
Yeah.
The phone rings with a problem, then you start digging. Mist tries to flip that entirely.
Right.
Uses machine learning, cloud analytics, all this data to give you proactive insights. The goal is to slash the time spent on manual troubleshooting and, crucially, shift the focus towards making the user's experience better.
That focus shift is massive. So the network stops being just pipes and wires and becomes, well, an intelligent system sort of managing itself.
Pretty much, yeah.
And when you talk intelligence, you inevitably get to Marvis, right? The kind of operational brain of it all.
Absolutely. Marvis, the virtual network assistant, is probably the most, let's say, visible part of the platform for many users. Its core function is really twofold.
Okay.
One, it provides really powerful AI-driven troubleshooting. And two, it handles natural language queries. Think about the old process. User says Wi-Fi is slow.
Ugh. Hours of pain.
Right. Hours, maybe days, SSHing into APs, checking controller logs, maybe even packet captures, trying to connect the dots.
It's like searching for a needle in a haystack blindfolded.
Exactly. Now, with Marvis, an admin can literally type in something like, why was Sarah in marketing's connection bad yesterday around 2 p.m.?
And it answers.
It does. It pulls data from everywhere wired. Wireless identifies the root cause. Maybe it was a congested switch port, maybe a known bug in the AP firmware she was connected to. It gives you real-time, actionable answers, proactive recommendations, too. It just makes managing the network feel more intuitive, much more efficient.
That intuitive part sounds great, almost like magic. But, it does raise a question for network folks listening. What if Marvis gets it wrong? How do you, as a human expert, kind of check or override an AI suggestion when the whole point is that it finds the root cause automatically?
That's a fair question, and it's where the human expertise is still absolutely critical. Marvis doesn't just spit out an answer in a vacuum.
Okay.
It shows its work. It provides the data, the context. Like, here's the SLE that failed, here are the data points that looked weird, here's who was affected.
So it gives you the why.
Exactly. So the admin isn't just digging through logs anymore. They're more like an auditor or a strategist. They validate what the AI found, use that context. Maybe they implement a bigger policy change the AI wouldn't try on its own, or handle a really complex edge case.
Got it. So the human role shifts up a level. Okay, we get the brain, Marvis.
Yeah.
But that brain needs a body, right? A platform that can support it, that's flexible. And this isn't built on old school monolithic code, which seems really important for being agile.
Oh, absolutely not. That's a key differentiator. The Mist Cloud architecture, it's fundamentally modern. It's a scalable, microservices-based platform. And it was built from the ground up for continuous innovation. That's a huge departure from traditional network operating systems.
Okay, maybe break that down a bit for us. Why does microservices matter so much in networking? Why is that better than just having, one big software program running in the cloud?
Yeah, good question. It comes down to speed and resilience. Think about a traditional monolithic network OS. If you want to add or update one feature, you often have to rebuild and redeploy the entire thing.
Which means long test cycles, planned downtime, risk.
Exactly. Huge risk. With microservices, features are like Lego blocks, small, independent services. If the Mist team wants to roll out a cool new location analytics feature, they can update just that one microservice.
Without touching, say, the part that handles logins or basic configuration.
Precisely. So two big wins. One, resilience. If one small service has a hiccup, it doesn't take the whole network down. Two, velocity. They can push updates and new features much, much faster. We're talking potentially weekly updates without service interruptions.
That's like web scale speed for your enterprise network. That's pretty impressive agility.
It is.
I
It's
mean,
a core design principle. But, okay, you've got this smart brain in the cloud, but network traffic still happens down here on-prem. So how do you securely connect that cloud control to the physical gear? That's where Juniper Mist Edge comes in.
Mist Edge, right. That's the bridge, connecting the cloud smarts to the physical needs on site.
It plays a really vital role. Mist Edge handles things like secure network access control. It basically extends the Mist Cloud's capabilities down into the local environment. Think of it as pushing some of that control and maybe some data processing closer to the users and devices. You need that for things like super low latency stuff, or maybe tunneling guest traffic or corporate traffic back securely. It needs that physical presence for performance and policy enforcement sometimes.
So it smooths out the connection and keeps things secure between the local network and the cloud management.
Exactly. Ensures seamless connectivity, secure data transit.
Okay, so that architecture explains how the platform can evolve so quickly. Let's switch gears a bit from the how it's built to how you measure success. Because managing an intelligent network seems like it needs a different kind of report card, right? You can't just look at swing up time if the goal is user experience.
You absolutely nailed it. That's probably the strategic core of the whole platform. Service level expectations, SLEs. Mist AI really shifts the focus here. Instead of just device health, SLEs measure tangible user experience metrics.
Like what specifically?
Things users actually feel, like connection success rate, did they actually get on the network? Time to connect, how long did it take? Throughput, was it fast enough? Roaming, did their connection drop when they walked down the hall?
This feels like a really crucial point for IT leaders listening. How does reporting on SLEs change how a network team works day to day, or maybe even how they justify their budget?
Oh, it changes everything because suddenly IT metrics are speaking the language of the business. When your team reports, hey, the time to connect SLE dropped below 95% in the sales wing last Tuesday, that's not a tech issue anymore.
It's a business risk. Sales reps couldn't get online quickly.
Exactly. It's quantifiable impact. It's not just AP12 is down, it's 5% of connection attempts failed, impacting productivity. SLEs let network teams show a direct link between network performance and user satisfaction or business operations. Makes it easier to justify proactive upgrades, too.
So the network manager becomes less of a plumber and more of a quality of service manager, focused on satisfaction, not just blinking lights.
That's a good way to put it.
And that user focus, it also extends into knowing where users are, especially indoors where GPS doesn't work, right? Location services.
Absolutely. And Mist has a really clever approach here for precise indoor location.
Yeah.
It uses BLE, that's Bluetooth Low Energy, but is virtual beacons.
Okay, virtual beacons. That sounds interesting, like they got rid of some hardware headache.
They did, a massive one. The really innovative part is these beacons are software-defined. They run inside the existing Wi-Fi access points.
No separate little plastic beacons to stick on walls and change batteries for.
Exactly. Forget installing, powering, maintaining hundreds or thousands of physical battery-powered beacons. It's huge operational and cost-saving. And because they're software-defined, you can deploy things like dynamic wayfinding in a hospital, or tracking assets in a warehouse, or location-based notifications really quickly and affordably across a whole site.
Very cool. Okay, so we've hit the intelligence with Marvis, the architecture with microservices and Mist Edge, and how success is measured with SLEs and VBLE. Now, let's bring it down to the metal. How does this AI stuff actually apply to the switches and APs? Let's start with the wired side.
Sure. So, Mist Wired Assurance. Its main job is delivering those AI-driven insights and automation specifically for the Juniper EX series switches. This is where the cloud smarts meet the physical configuration.
Okay.
And it's not just passive monitoring. The focus is on automating provisioning, making setup easier, but also continuously monitoring for weirdness, for anomalies, and optimizing things to keep the wired side reliable. Like it might detect a bunch of errors on a specific port, and then automatically cross-reference that with user experience data from Marvis, see if anyone connected to that switch had issues, and then flag it for action before it becomes a bigger problem.
So applying that cloud analytics brain down to the copper and fiber level, Makes sense. And then the counterpart, wireless assurance, handles the Wi-Fi side, which is often where users feel the pain most directly.
Correct. Mist Wireless Assurance is all about AI-based optimization of Wi-Fi performance and user experience. Same principle. Real-time monitoring, anomaly detection, trying to keep that client experience smooth.
So if, say, a bunch of laptops in one area suddenly start failing to connect.
Wireless Assurance sees that deviation from the normal baseline, that drop in the SLE, and Marvis immediately kicks in to figure out the root cause using all that cloud data.
Right.
Is it interference? Is it a misconfigured AP? Is it a client-side issue?
Right. And this brings us to something you mentioned earlier, the proactive bit. It's one thing to analyze failures after they happen, but how does the system actually get ahead of them? How does it predict trouble?
Yeah, that's the goal with the predictive operations capabilities.
Yeah.
Mist AI works by trying to predict issues and suggest corrective actions using machine learning. It's constantly looking at millions of data points, how clients behave, switch loads, traffic flows, everything, to build this dynamic baseline of what's normal for your specific environment.
Okay, predicting issues sounds, well, almost futuristic. But what does a network admin actually do with a prediction?
They get to act strategically, not just reactively fight fires. The platform might spot subtle things. Maybe a switch port's utilization is creeping up in a pattern that historically leads to congestion. Or there's a tiny uptick in connection failures for a specific device type that hasn't actually broken the main SLE threshold yet, but it matches patterns seen before major outages.
Ah, so it sees the warning signs.
Exactly. It flags that anomaly before it causes real pain for users. And often it suggests a specific fix. Consider changing this config, or this AP might benefit from this firmware update. It lets the admin get ahead of the problem, potentially avoiding any user tickets altogether.
That predictive power seems like it has to be linked tightly to the last piece we should cover, integration. If the AI is predicting problems and suggesting fixes, it needs to talk to everything else, right? Ticketing systems, identity tools, maybe even configuration management databases.
Absolutely essential. And that's addressed by the platform's integration approach. Mist AI simplifies all that network automation and integration by offering a comprehensive RESTful API for basically all management functions.
Comprehensive is the key word there, I guess, meaning anything you can click in the dashboard, you can automate via code.
That's the idea. That's the power. It's an open API structure, which allows for smooth two-way communication with third-party systems. Think about the workflows this enables.
Right.
Well, maybe a high-priority ticket opens in ServiceNow. That could automatically trigger Marvis to run diagnostics on that user's connection. If Marvis finds a fix, the API could potentially push the necessary configuration change straight back to the switch or AP involved.
Without a human needing to manually type commands.
Potentially, yes, for certain types of issues. That's genuine end-to-end automation starting to become reality. Well, thank you for joining us for this deep dive into the strategic side of AI-driven networking.
My pleasure.
We'll catch you next time on The Deep Dive.